All right, today we're going to graph sine and cosine functions, and also I don't know why it just says that. Also going to graph tangent, cotangent, secant, cosecant. So we're really going to graph all of them, and this is just meant to be an introduction to it. So I want you to get as much as you can and really look for the pattern of how things are working. And we will really, I can help you more in class tomorrow, so don't feel like you have to get everything from this video, but get as much as you possibly can, and please take good notes. All right, there's the unit circle we've been working with, and a couple things I want you to notice about it. First thing is, if you look at all the x and y coordinates, no matter where you look here, there, all the x and y coordinates, you will not see a number bigger than 1 anywhere. You will see 1, you will see -1, but all the other numbers are less than 1. And you can also, thing I want you to think about the unit circle is like, that's 1 pi if you go that far, that's 2 pi if you go that far. You could keep going, 3 pi, 4 pi, 5 pi, 6 pi. So you can do that as many times as you want to. You can even go negative. You can go negative pi, negative 2 pi, negative 3 pi, negative 4 pi, I'm making a mess, negative 5 pi. So what I'm saying that to say is this. The domain of sine and cosine, which is your x values, go from negative infinity to positive infinity. And by domain, we haven't talked a whole lot about domain yet this year. That's coming pretty soon. But the domain means how far your graph, really, if you're going to graph something, it's how far your graph goes left to right. What are your x's? What part of the x-axis does it cover? How far left and right? And when we graph sine and cosine in a minute, it's going to cover the whole thing. It goes forever left, forever right. The range, because the values I just showed you in a unit circle are never less than -1 or greater than 1, the range of both graphs goes from -1 to +1, meaning range is your y. If you look at how far up and down your graph goes, it's not going to go down below -1 or up past 1 unless there's a vertical stretch. All right, so here's what the sine graph looks like. Let me explain a couple things to you here. First of all, notice there are arrows on the end. I don't know if you can see that or not. There are arrows on the end. It doesn't stop here either place. It keeps going forever because the domain goes from negative infinity to pi. It goes left and right forever. All right, now, the way we're going to key in on it is this. That's 0. Sine of 0 is 0. That's why it goes to the origin. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is -1. Sine of 2 pi is 0, because when you get back to 2 pi, you're right back where you started at 0. So when you get there, the pattern just starts over again. The period, right? The period is 2 pi, starts over again. You can also go the other way. Negative pi over 2, sine is -1. Negative pi, sine is 0. Negative 3 pi over 2, sine is 1. Negative 2 pi, you're back where you started, and again, you can start it again. One period is where it starts repeating. So from here to here is one period. From there to here is one period. The graph is exactly the same, and it just repeats over and over again every 2 pi. So between 0 and 2 pi, it repeats. Cosine, same way, except it's flipped a little bit. At cosine of 0, you get 1. Cosine pi over 2 is 0. Cosine of pi is -1. Cosine 3 pi over 2 is 0. Cosine of 2 pi, which is the same thing as the 0, is also 1. And you can go backwards. Negative pi over 2 is 0. Negative pi is -1. Negative 3 pi over 2 is 0. Negative 2 pi is 1. So, same deal. From here to 2 pi is called one period. From negative 2 pi to 0 is one period. Every 2 pi, if you look at the patterns in between those blue lines, it just repeats itself over and over again. And I'm going to help you with a little gesture tomorrow. Remember how to draw sine, how to draw cosine. But that's what they're going to look like every time, sine and cosine. Again, it's going left and right forever. There are arrows, even I'll just box those in. There are arrows at the end of the graph. Both sides, it goes left and right forever. Does not go below -1, does not come up above +1. All right. If you're going to graph just a sine, watch, here's how I'm going to ask you to kind of do it. This is kind of the easy way to do it. I was taught this way back years ago. We're going to draw 4 slashes, just like that. The fourth one's going to be the end of our period, which is 2 pi. Halfway is going to be 1 pi. And up here's 1, there's -1. And for sine, you have to know where to start the graph. Sine of 0 is 0, so I'm going to start it at 0. Every single one of these 4 slashes, something happens. Like the first slash, you're up at 1. Second slash, you're back to 0. Third slash, you're at -1. And fourth is 2 pi, or back at 0. And the reason it does that is because that's what the values are. Sine of pi over 2 is 1. That's why I put that first one. Sine of pi is 0. That's why I got the second one. Sine of 3 pi over 2 is -1. Sine of 2 pi is 0. So if you graph that, just connect the dots like that. That's one period. You could go backwards. You could go backwards this way and do another one. It would keep going like that. You could extend this x-axis out this way, and it would it would keep going like it was, same kind of pattern. But one period is going to be between 0 and 2 pi. And that's what we're going to concentrate on for now. Cosine, same way. Let's go 4 slashes. 4 slash being 2 pi. Halfway to 2 pi is 1 pi. Let's go 1. Let's go -1. Now the difference is cosine, instead of starting at 0, because cosine of 0 is not 0. Cosine of 0 is 1. Pi over 2 is 0. Pi is -1. 3 pi over 2 is 0. 2 pi is +1. Just connect here, just like that. And again, you could keep going the other way. I could start this one. It would start the same pattern coming down again, like that. I could extend this axis over here, draw some more slashes here. It would start the same thing, same pattern. But every time between 0 and 2 pi is one period before it starts just repeating itself again and again and again. Okay, the word period is important. The period is the repeating pattern. For sine and cosine, it starts repeating after 2 pi. Amplitude. Amplitude is how far up it goes from the center. I put half distance from the max and min. We've been drawing like this, and the graph's been doing like this. So, that's 1. That's a -1. Our amplitude has been 1 because from the halfway point, or do this, from the max to the min, is 2. It's 2 from -1 to +1. So half that distance is 1. Or you can like this, from the halfway point up to the top is 1. So the amplitude, two ways to look at it. How far up from the midline does it go? Or half of bottom, minimum to maximum. It's called amplitude. Okay, I'm going to graph one now and change the amplitude. Here's the good thing about amplitude. The number in the front is your amplitude. So there's no guessing kind of what your amplitude is. Number in front is it. And what's going to happen is instead of going up to 1, we're going to go to 2. That's our new amplitude. And because it's sine, I'm going to do my 4 slashes. That's 2 pi. That's 1 pi. Sine starts at 0. It goes up, down, back up. So if I graph it, it does this right here. That's one period if the amplitude is 2. And obviously it does keep going. Let's do the cosine one now. The cosine one, if you look at it, it says y equals, let me move it over a little bit, it says y equals 1/2. So the 1/2 becomes your amplitude. And so what happens with the 1/2 there is, instead of going all the way up to 1, we're just going to go to 1/2 and -1/2. And I'm still going to do the 4 slashes, 2 pi, 1 pi. Cosine does start as, no it doesn't, I just messed that one up. Cosine starts up, then it goes down, down, back up, then you just connect the curve, and there it is, there's the cosine, 1/2. But again, it just went up to 1/2, down to -1/2 because that's what the amplitude was. Pretty simple. All right, tangent, whole different story. Tangent's undefined. Remember, tangent is this. Tangent is sine x over cosine x. So wherever cosine equals 0, tangent's undefined. Well, cosine is 0 at all the power 2's. And if you look at these at all the power 2's, those broken lines are called asymptotes. And asymptotes are basically lines that the graph cannot cross, can't touch, but what does happen is the graph gets closer and closer to the asymptotes as it goes. And if I were to plug in points, you're like, that's pi over 4. Well, tangent pi over 4 is 1. Tangent negative pi over 4 is -1. That's why the graph is doing that. So the period of tangent is in between the asymptotes. All right, and that's the shape every time you see a tangent. Cotangent is going to be just two things different about cotangent. One, the graph is going a different direction. And that is because cotangent, instead of sine over cosine, is cosine over sine. So wherever sine is 0, that means cotangent's undefined. And sine is 0 at -pi, 0, pi, 2 pi, basically all the pi's. Remember, cosine was 0 at the pi over 2's. Sine is 0 at all the pi's. So there's asymptotes there. and the graph gets turned around because it's reciprocal. I mean, it's just been flipped. If you want to think about that way, the graph's been flipped. All right, this is just a quick run through real quick of cosecant. Remember, cosecant is reciprocal of sine. So when we graph cosecant, we're just going to, first thing we're going to do is we're going to graph sine. If you look at the lighter graph right here, the lighter graph is that right there, that's sine. Now, cosecant is 1 over sine. This is important right here. Cosecant is 1 over sine. So wherever sine is 0, cosecant's undefined, or you can't have a value there. So here, watch what happens. Everywhere that sine touch the x-axis, like here, there, 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 everywhere sine crosses the x-axis, cosecant's undefined. So we had to draw asymptotes there because our graph can't cross those because the graph isn't defined at those values. So the cosecant graph gets closer and closer to the asymptotes, as you can tell, and it's basically, think about it, cosecant's the reciprocal of sine. You just take the sine graph in between the asymptotes, flip it, take it, flip it, take it, flip it, take it, flip it. All right, cosecant. Now, secant is the same thing except it's cosine. So what we do is we graph the cosine graph like we always do. All right, wherever cosine is 0, secant would be undefined. Well, cosine is 0 here, here, everywhere it touches the x-axis. X-intercepts are called zeros. That's another name for x-intercepts, is zeros. So I drew asymptotes right through there. And again, the graph can't touch the asymptotes, but they get closer and closer. So all you do is like what you'd expect. You know, you take your cosine graph, you flip it. Your cosine graph in between your asymptotes, you flip it. Your cosine graph in between asymptotes, and flip it. So that's what secant looks like. That's a lot of information on one video. I know it is, and we will break it all down tomorrow. I promise you. Give you a couple of gestures that will help, and we'll spend some time graphing these, obviously. And hopefully, by the time you leave class tomorrow, everything is good. We'll check it out. We'll see you tomorrow. Look forward to it. See you. Bye.